We're asked to use the first derivative test to locate the x value of all extrema. Then we're asked to classify if it is a relative maximum or minimum. In this case, we're given a function f of x equals x times e to the power of 1 over x. Now, what we're going to have to do with that is we are going to first have to find the first derivative. I see that we have this function, and since I see things being multiplied and functions inside of functions, I know I'm going to have to use the product rule and the chain rule. To remind us, the product rule tells us that if we have a function that's two functions being multiplied together, its derivative is going to be f prime g plus fg prime. And so, in this case, let's find our derivative. F prime of x equals f prime, in this case that's just x, so we do 1, times the second function, which we keep the same, e to the power of 1 over x, plus, and in this case we work with the first function, we keep it the same, and so that's just x, times the derivative of the second function. Remember, for e, we just keep it exactly the same for the first step. And then, when we apply the chain rule, we have to find the derivative of that numerator. Or not numerator, sorry, exponent. And here it's 1 over x. As a reminder, 1 over x is the same thing as x to the power of negative 1. So the derivative of x to the negative 1, we just apply the power rule. That'll be negative x to the negative 2. Or negative 1 over x squared. And so I'm going to write that here, times negative 1 over x squared. Alright, we get our derivative here. This is just e to the power of 1 over x, plus, alright, this e to the power of 1 over x here, times that x, I'm going to put in the numerator here, negative x over x squared. I can rewrite this here, negative x over x squared, as negative 1 over x if I just cancel one of the x's out here. So this becomes e to the power of 1 over x plus e to the power of 1 over x times negative 1 over x. I see that I can factor out an e to the 1 over x from both of these terms. So my final derivative I get is e to the power of 1 over x times 1 minus 1 over x. Alright, so we have our derivative, and now what we need to do is we need to find where are the critical points. As a reminder, the critical points happen in two locations. The first way, I'll write this over here, is that when is f prime undefined? Well, remember, things are undefined when we get a denominator of 0, when we get logs of 0 or negative numbers, or when we try to do the square root of negative numbers. And here I don't see any square roots, I don't see any logs, but I do see a denominator. And I know that if I put x equals 0 here, I would get two different locations where the denominator is 0, and I don't want that. So I know that f prime is undefined when x equals 0. That's going to be some critical point. Might be a maximum, might be a minimum, might be something. Who knows? The second time is when f prime equals 0. Where might that happen? Well, let's try to do it. 0 equals e to the power of 1 over x times 1 minus 1 over x. Now, in this case, we're going to use the zero product property, which means one of these two things will equal 0. So e to the power of 1 over x equals 0, or 1 minus 1 over x equals 0. This first one, there's no possible way that this will ever equal 0. It'll get really close to 0 with really big numbers for x, but it's still not going to be 0. So we're going to disregard it. But this other one, I'm going to add 1 over x to both sides. 1 equals 1 over x. And I know 1 divided by what equals 1? 1. So x equals 1. Alright, so these are our two critical points. But we need to figure out, are they both allowed in the domain? We look at that, for that we have to look at our original function. And I'm going to write over here. Is x equals 0 allowed? And when we look at it, we're going to see that the answer is no. Because if we put x equals 0, we would get 1 over 0 in that exponent of e. And so the answer is no. It's not a critical point, and it's not allowed. The next value that we want to look at is x equals 1. Is x equals 1 allowed? And yeah, there's nothing that's keeping x equals 1 from being an issue. So yes, it is allowed. We're allowed to have x equals 1 as a critical point. Now the final bit of this question, and I know this feels like it's a lot, it's just because I'm walking through every single step and discussing it, is setting up our chart in order to figure out where the maxima and minima are. Remember, we still want to look at x equals 0, but it can't be a maximum or a minimum. It's going to be some sort of asymptote at that location. And so we set up our chart with our x values and our f prime of x values. I set up my chart. We want to have 0 and 1. 0 and 1. We know that at 0, the derivative is undefined, and at 1, the derivative equals 0. All right, but what about in these three intervals? Let's check here, because this is going to tell us if it's a maximum or a minimum, if it's increasing or decreasing. And so what we do is first we want to look at values less than 0. So into the derivative, which remember is right up here, into the derivative, we're going to plug in values that are negative, right? Very, very, very big negative values. And so f prime, actually I can just even do f prime of negative 2. Let's see what happens. E to the power of 1 over negative 2 times 1 minus 1 over negative 2. E to the power of anything is going to stay positive, right? Even if it's a negative fraction. And so that's going to be a positive number times 1 minus 1/2. That's 1 plus 1/2, which is, or 1 minus negative 1/2 is 1 plus 1/2. 1 plus 1/2 is just 1.5 or 3/2, which is positive. So this is going to end up being positive. Sorry, just wait one moment. My thing, there we go. Positive. All right, so we have here is positive. There we go. Now between 0 and 1, we can test like 0.5, right? F of 0.5, or f prime of 0.5, sorry, equals e to the power of 1 over 0.5 times 1 minus 1 over 0.5. This is going to be positive times a negative, because 1 minus 1 over 0.5, 1 over 0.5 is the same thing as 2. So 1 minus 2 is negative 1. So here we're going to end up with a negative. And so you might think, because we go from positive to negative for our value of f prime, this would be a maximum. However, we already said up here that x equals 0 is not allowed. So we're not looking at x equals 0. We just need to make sure that we're looking around there to think of what happens. Now the final part is 0 to infinity. We can just check the number 2. What happens when we do that? F of 2. Or actually, let's do 1. I like 1 better, so we're going to do 1. Oh no, this should be 1 to infinity. I messed that up. That should be 1 to infinity. And so this should be f of 2. F of 2 equals, or f prime of 2, sorry, e to the power of 1/2 times 1 minus 1/2. Again, we see here that this is a positive times a positive, because 1 minus 1/2 is just positive 1/2. And so this will end up being a positive value. So because we're going from negative slope to positive slope, I'm going to draw that on the right here. Negative slope to positive slope, that is a minimum. And so we see in the end that the only extrema that we have is x equals 1, and that is a minimum because f prime changes from negative to positive. And actually, we should be a bit more specific and say that x equals 1 is the location of a minimum. Location of a minimum. Because f prime changes from negative to positive when x equals 1. This might have felt like a lot of steps. Again, it's just practice. Once we get through it over and over and over again, it's really not as bad as it might seem. The first time we do it, it will be long. You've got more and more opportunities to test these things out. Best of luck with this question, and if you need to review it, please let me know.